Tell you a story about the SolarDust. The name already implies that it's somehow related to solar, the solar energy, and dust particles in the atmosphere, which tend to be quite magical in what they can do and how they can affect our lives. This is going to be a forecast system for the solar energy with some specific features which are not currently present in the market. This is a very nice image which has been in the media for a while. It's been published everywhere. It shows that aerosols are present all around the world, different types of aerosols. And here what gets the most intense color, which is most interesting for our project, is this orange color in what we call the dust belt, which is something covering the deserts in the Sahara, Middle East, also reaching Mongolia. And also there are some deserts which are a bit further away in the southern hemisphere, like Australia, or in the Latin America, even in southern Africa, but it's covered by other types of aerosols in this case. So, what's going on? If we want to use solar energy, which we say that we do, given that we are trying to switch to renewable resources as much as we can, wherever we try to place the solar panels, we want to find the sunny area. And sunny areas tend to be in the deserts where there is quite a lot of dust around. Here we can see the two very typical types of solar plants. One which directly is photovoltaic, using the converting energy coming from the sun, and one which uses mirrors to concentrate the energy. So both of these are heavily affected by dust, and even in one very interesting example that the presence of dust can cause losses of like 20%, even a little bit above, in solar energy production, depending on the type of the solar plant. How does this happen? What does this dust do? What's going on with this? So, directly radiation coming from the sun can interact with the particles in the atmosphere. These particles are flying around in the air. The dust can be absorbed, the energy can be absorbed or scattered. Also, dust particles can help, not produce, but participate in the production of clouds, which also clearly affects radiation. And one of the very interesting process is called soiling. So the dust gets deposited directly on the solar panels, basically making them dusty or dirty, reducing the production. Soiling is shown to be the third most important performance factor, behind only insolation itself and the temperature. What's going on? We've seen that, and this is an example from Germany, but around the world we have an increase in use of solar energy around the world. And so this is definitely on the rise. While the dust affects this clearly in several ways. So there is a reduction in the photovoltaic just by presence of dust and making the panels dirty. There is shown that the soiling, which is already mentioned as one of the most important factors, can reduce up to 6% in the power loss. And there could be savings made especially in the CSP type of plants, which can be quite significant depending on how we address the maintenance. How are we going to deal with this? We, at the BSC and the Atmospheric Composition Group, we are developing an atmospheric dust model. What does it mean? The typical model which you use when you watch weather forecasts doesn't deal with the dust particles, but it gives you, there are a lot of equations there explaining how the atmosphere is changing. So this model includes also the information of the equations about dust concentration and dust deposition on the solar panels, coupled with how it affects radiation. So what happens? Why is this solution useful? Our solution is predictive. Typically, if you have a solar plant, you would have some measurements seeing how much there is soiling, how much there is an issue with the dust, but we can predict, and this will affect your maintenance, and it can also affect your market outputs. Why is our team so good at this? We are at the top of the research. We have HPC resources. We are participating, really, we put our hands in the dust. We go into the deserts and perform measurements. We have really up-to-date information. We're working with NASA on a mission with the International Space Station, getting mineralogical information about the dust, which makes us at the top of the game. And what are we about to do? We want to tune the model. We want to use all this information that's available for us through these experimental campaigns and these interactions. We need to validate the model, and then we want to try working with clients and get some feedback in order to produce a very useful product for them. Thank you.